Hey guys, this is Kerry, and in this video we're going to be doing the answer key to a group quiz for Unit 4. So taking a look at problem number 1, 2, 3, and 4, these all involve an idea, which is you start off with a basic parabola, and then you want to shift that parabola so that it becomes the black parabola. And so to do this in each of these cases, you're going to be using a combination of inside and outside transformations. So all of your equations are going to look something like y equals x with some number inside squared and some number outside. And that plus sign may change to a minus sign sometimes. So we've got an inside and an outside transformation. So starting off with problem number 1 here, because the move is only in the vertical direction, it's going to be only an outside transformation. So we get y equals no inside transformation, so just x squared, and then an outside transformation of minus 6, because outside the sign matches the direction that you go. For problem number 2, we're going to be moving only in the horizontal direction. And so this one is only going to have an inside transformation. So for this one, we have to move, it's hard to count with all of that stuff down there. So 1, 2, 3, 4 units to the left. So you would think that that would be minus, but inside is always the opposite of what you expect. There's no outside transformation because you didn't have to move it up or down. For problem number 3, you've got y equals, you're going to move it 3 to the right, 4 up. So x minus 3 inside, because it's 3 to the right, opposite of what you expect. And then in the vertical direction, 4 up. The last one of these I'm going to leave for you to figure out, because it's very similar to the ones that we just did. Just keep in mind that inside is always the horizontal direction, outside is always the vertical direction. Which of the following equations has x-intercepts at 1, 2, and negative 3? So we saw that to find the x-intercepts, those come from setting y equal to 0. And the reason why you do that is if you're at the x-intercept, all of these points have gone neither up nor down, so they all have a y-coordinate of 0. So if we want to get these as the answers to our equation, we need to figure out, okay, well, the whole thing needs to equal 0, because y is equal to 0. So to make it so that 1 creates a 0, we need x minus 1 as a factor. To make it so that 2 creates a 0, we need x minus 2 as a factor, because plugging in 2 would give you 2 minus 2, 0. To get negative 3 as an intercept, you need to have the opposite, x plus 3. And so it looks like y is totally wrong. Sorry about that. It looks like problem choice 3 is totally right. Okay, let y equal 2x squared minus 10x minus 12. Which of the following are the x-intercepts of this function? So x-intercepts have a y-coordinate of 0. So we're going to start by making y equal to 0. To solve this equation, we can divide by 2 on both sides. That gives us 0 equals x squared minus 5x minus 6. 0 is equal to x. And now we can solve this with sum and product factoring. We're looking for two things that sum to negative 5 and have a product of negative 6. It looks like that's going to be negative 6 and 1, but don't take my word for it. You should definitely check it. This is not the solution, though. In order to make this equal to 0, we need x minus 6 to equal 0, so x is equal to 6, or x plus 1 to equal to 0, and then x is equal to negative 1. So it looks like choice 1 is our first answer. For problem number 7, which of the following is the equation of a parabola that is upside down? So it's going to have a negative a value. Well, all of them do, unfortunately, so that doesn't let us eliminate a choice. Narrower than y equals x squared. In order to make it narrower than y equals x squared, what you do is you want to take each of these points and stretch them so that they're higher up. So to do that, we need a to be greater than 1, or it needs to be a big negative number. So a could be less than negative 1. So a number like negative 2, negative 3, negative 4, or whatever. So we can eliminate the fractions because that would actually flatten it out. Those would lower the heights of those points, and we don't want it to have that. We want it to be narrower, so taller and thinner. And then next up, we need to find the vertex of 3, negative 4. So y is equal to x. The transformation, we have to move it 3 to the right, so minus 3, opposite of what we expect inside. 4 down, so minus 4. And then, let's see. Oh, I guess it has to be this one, -7, because the other one has the wrong vertex. Which of the following are the solutions to the equation x squared plus 6x minus 31 equals 0? So we can try this one with sum and product factoring, but there's not very much that multiplies to -31, only 31 and 1. And no matter what combination of signs you use for that, it doesn't add to 6. So sum and product factoring is out. So instead, we need a better number here. So let's get rid of that 31 that we have. X squared plus 6x, having a gap there, equals 31. And this is the method of completing the square. And so we think about, okay, well, we want to get the same thing here and here, so we could write it as, oops, it's not going to equal 31 anymore. The same thing here and here, so we can write it as that thing squared. So it looks like we need 3 and 3 to give us the 6 when we add them, which means that we really wanted to have a plus 9 here. But if we add a 9 to this side, we have to add a 9 to this side too. So we end up with 40. So we get x plus 3 squared equals 40, and then we write down the solution by solving in our heads, or you could show the steps, whatever you prefer. And we notice that that's none of the answer choices. So unfortunately, we need to break 40 down. So breaking 40 down into 10 and 4, 2 and 2, 2 and 5, gives us x equals -3 plus or minus the square root of. Because this is a square root, we group them as squares, and that's the only group we can make. So we get x is equal to -3 plus or minus. Square and square root cancel, giving us 2 square root of 10, because the 10 is left inside. Problem number 9, let f of x equal this, which of the following is the vertex? So straight up vertex form, really nice. So we've got an inside transformation of -3, that moves us 3 to the right, because it's the opposite of what we expect. And then an outside transformation of +1. So we go right 3, up 1. And it's going to be, what does this 2 do to it? The 2 just makes it twice as tall and narrow. So it's going to be a taller, narrower parabola. So the vertex is 3, 1. All right, all of these are actually pretty much the exact same question about the vertex, just phrased a little differently. So let's see why. This one has equation -3 times x minus 1 squared plus 5. So we move it 1 to the right, because it's the opposite of what we expect. 5 up. And then this time, because our a value is -3, it's going to be super steep and upside down. So because it's super steep and upside down, if we're trying to find the range is going to be, looking on the y-axis, all of the y values that are included. So if we think about that, we never hit any y values up here. So, ooh, wow, I don't want to move the y-axis. We never hit any y values up here, so we have to lower that. The only y values we hit are the ones below this line. So we only hit y values that are less than or equal to 5, because that was the peak value, the vertex that we hit. So all the y values less than 5 get hit. Consider the function h of x equals -2, x plus 6 squared minus 3. Which of the following inequalities describes the interval where h of x is increasing? So we've got this right here. Inside transformation is +6, so we move 6 in the opposite direction. Inside is always left or right, 4, 5, 6. Outside is always up or down, so we go down 3 because it matches, and we've got our vertex there. And now we're going to have an upside down parabola because our a value is negative. So we want an inequality to describe where it's increasing. So whenever you read a graph, you start at the left and you read it from left to right. And as you see, the height of these points is always increasing until we reach here, and then the height starts to decrease. So we want an inequality that gives us only the left half of this equation, or this graph. So if you think about this left half, the boundary here is -6 on the x-axis. So we want only the values that are less than -6. For problem number 12, a parabola and its directrix have been graphed above. Which of the following is the coordinates of the focus? So we know that for the setup here, we've always got directrix, then the vertex is in the middle, And on the opposite side, being engulfed by the parabola is the focus, and they're always equidistant. So this was 4 units. This will be 4 units as well. So this is the focus right here at 1, 2, 3, 4, 5, comma, and make sure you're counting from the x-axis down, 1, 2, 3, 4, 5, 6, at 5, -6. All right, a parabola has focus located at 5, 7, and directrix with the equation y equals -3. Determine the equation of the parabola. So a picture always helps with these problems. So focus is at 5, 7. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So here's our focus. The equation is y equals -3, so 1, 2, 3. And so these have a total distance of 10 between them. And so it looks like since the total distance is 10, it'll be 5 away from each of them. So 5 up from here or 5 down from here gives us the point 5, 2. And it's going to be an upward facing parabola because it's going to engulf the focus. So y is equal to x minus 5 squared plus 2. And now we need to calculate our a value right here. And so our a value is going to equal 1 over 2 times the total distance. And the total distance we saw before was 10, so it's going to be 1 over 20. I feel like I keep making it 1 over 20. Sorry, guys. Next, a parabola has x-intercepts at -1 and 2 and passes through this point. So we've seen a couple of times in this group quiz already that the factors and x-intercepts are superconnected. So our equation must be y equals x opposite of -1, so that -1 is a solution, opposite of 2, so that 2 is a solution, and then the a value will be some mystery value that we still need to find. So we get y is equal to that, and I don't need to rewrite that. Because now what we can do is, since we have this extra point that our graph goes through, we can plug in that point. So 2 is equal to, or 12 is equal to a times, and it's -12, 3 plus 1 times, plugging in 3 for x, 3 minus 2. -12 is equal to a times 4 times 1. -12 is equal to 4a, divide by 4 on both sides, a is equal to -3, and we get y is equal to -3 times x plus 1 times x minus 2. And we're all set. Hope you guys got something out of this video, and I'll see you in class on Thursday for your test. Good luck.